Welcome to MLOps Live, a podcast by Neptune.ai.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches.
Welcome, everyone, to another episode of MLOps Live. My name is Steven, one of the co-hosts of MLOps Live. And unfortunately, my co-host Sabine is not here for this episode, so she'll be available for the next, of course. So if you're fans of Sabine, just anticipate the next one on that case. So in this particular episode, we're going to be hosting Laszlo Sragner, who is an ML consultant and also currently the founder of Hypergolic, and of course as well one of the most notable voices in the MLOps community on data scientists adopting best practices or best coding practices. So you're really in for a ride in this case. Laszlo, did I miss anything in your intro?
No, thank you very much, Stephen. You're very kind for the introduction. Very happy to be here and happy to answer your questions.
It's perfect. Thanks, Laszlo. So before we delve right into the questions, I have just a few housekeeping rules. So if you're streaming live, maybe from LinkedIn or right here, of course, on Zoom, if you have any question, please drop your questions in the chat. We'll do well to attend to them. If you have on LinkedIn as well, please drop your questions in the LinkedIn comment box. So we'll get to them, of course, here. Just jump right into the particular episode. So yeah, Laszlo, we usually have this 1 minute, explain this in 1 minute question. We start our episodes with to give an insight or overview or context into this particular episode. In 1 minute, can you sort of give us an insight into clean code, what clean code is, and why it should be a topic of concern for data scientists?
Yes, of course I can.
1 minute.
Code is like an umbrella term for actually caring about your work. We know that data science is started with analysis, and often it's relatively unprepared to care about this. And when we moved from data science to machine learning, where you would need to create something and then ship it and maintain it over the long term, it became an issue. And this is not just analyze, where it doesn't really matter how do you end up at a value. It just matters that the value is right. So you don't care about the code, and you throw it away. And in clean code, you take care of it. It is a paradigm that you actually need to think about what you are going to do in 6 months' time, how you are sharing this code, not just the values with your team, and being more conscious about how do you write code. That's
perfect. I think that fits right into a little bit over, but yeah, that fits right into the intro, I would say. So yeah, just starting out with an article you particularly wrote, and one I found really insightful on the data science code quality hierarchy of needs. I think the concepts you shared there will really give a context into this particular episode, of course, and why this is really an important topic to sort of consider. Could you explain what the hierarchy of needs in terms of like code quality are for data scientists and how they can influence ML products?
So we are starting from like a position. When you say code quality or production grade code, people would start thinking is that, okay, this is something hard that Google does, all right? And large scale enterprise companies do. And sometimes they mix DevOps and MLOps concepts into that. And we want to clarify that this is an easy to learn, small set of tools that you can make yourself much more productive if you apply to your work. And to do that, this is like a democratization work. So I don't think this is a particularly hard subject. It is not taught anywhere, but everyone is proficient in statistics. I do think that anyone who can get proficient in statistics will be able to learn these concepts. And the reason why I wrote Your Needs, there is a lot of moving parts here, all right? Like a lot of new concepts. They are not difficult altogether, but there is a lot of them. And I wanted to have a straightforward list. You can start at the top and then take one at a time and then go down, and then you can assess whether your progress. Do you care about the right things? Are you worried at this level of the learning curve about the right thing? And this is what hierarchy of needs. So it is designed to be a learning curve, an optimal learning curve for any kind of beginners, like someone who is just starting about this.
Yeah, and can you share those step-by-step processes? Because, of course, in the article, we talked about the starting out with versioning, which is a really important part of like the experimentation process. Maybe we can walk us through, yeah.
Yeah, so usually this is starting with version control. So what is version control? This is usually said Jeff Bezos have this kind of type 1 and type 2 decisions, which means that type 1 is that can ruin you. Type 2 is something that you can instantly make and then you can back out of. Therefore, you can, when you have version control, you can turn every kind of decision into type 2 decisions, all right? Because it means that if I make a mistake and I don't remember how did I ended up in this situation and my code doesn't work anymore, I can go back to this. So this is why I put this at the first place. So the next one is functional testing. So what is functional testing? I run my code, I change it, it does the same thing, right? So you fix the inputs and outputs and then rerun the code. Without testing, there is no refactoring. So it means that just to have this kind of routine of changing your code without any kind of worry, you need version control and then you need testing, right? And then the next one is refactoring, right? Refactoring means that I'm not going to do anything material to my code base, but I'm going to move code around. And then you get used to actually changing your code. There is this kind of red flag, what I usually see in data science teams when they say, oh, I don't want to touch that because I'm worried that it's going to break. That's the clearest sign that you have problem, right? Everyone on day one, when they join a team, they should be able to change the code. If it breaks, that's great. You are just going to revert to the previous version. And that's the most important one. And the first one, which I would think is material to clean code and code quality, is decoupling. This is the first concept that you need to learn, and probably the most important concept when you are start constructing smaller bounded contexts where you can think of one problem at a time and not worry about anything. And this is decoupling. So both Kahneman and Osterhut, these are two like big software strategy people, and then Donald Knuth is like famous for his algorithm book, said that the most important problem concept in problem solving is decomposition. Without decoupling, you can't do decomposition. And this is usually what you see in data science projects, is that all of their problems are problems at the same time. And this creates like a mental overload that you are unable to forget about some parts of the system, focus on one, solve that one problem, package it, keep it, and then move on to the next problem. And this is what decoupling does, right? And then there is a lot of like other clean code techniques like compose instead of declare and data modeling and readability. You can argue which is the exact order, but once you reach decoupling and you probably understand like dependency injection, then you are in the right track. It means that you are starting to be creative and you can write code without worrying, and then you can see more structured about these problems. And then one important thing is layers of abstraction. That's a primary organizational principle, is that you think about high-level problems, and then sometimes you face a small problems. You can forget the high-level problems and then focus on that particular aspect, and then you can move back. And this is a very important like organizational principle that you're using all the time when you are having a clean code framework. And deliberately, I put a lot of the problems that I think are not too important down the list, because often these come up as important issues when someone says clean code, which means typing or unit test. It's like, and maybe they are not the first thing what you should start with, because the most important one is to get used to changing your code in a deliberate manner, right?
Right. Absolutely. And you spoke about layers of abstraction. And I think this is one of the crucial parts of building systems with clean architecture. Is sort of clean architecture something that data scientists should be worried about? Or it's just like, let's leave that for the software engineers to figure out, especially, when building ML products?
Okay. So in a team, usually there are like team problems and then there are individual problems. And obviously, data science is a team sport, right? So you have software engineers, you have data scientists, you have MLOps engineers, DevOps engineers, you have non-technical people, stakeholders. Everyone needs to collaborate together. And we find that clean architecture is a very good high-level principle where everyone can find its role, right? So it means that, okay, they can have a shared mind space, all right? They know who to talk to what and who's responsible for which part. So clean architecture with these layers have a place for everyone, and then an interaction mechanism to everyone else. And this is exactly what, obviously, if you're a single data scientist in a startup of 10 people, are you doing clean architecture? Yes, it is. Of course, it's your problem. But then you are doing alone. And on Monday and Tuesday, you are, let's say, a stakeholder. And then Thursday and Wednesday, you are a data scientist or software engineer, and then worry about that part of the clean architecture. But maintaining it for yourself is a very important structure.
Yeah. And obviously, I think the main goal, of course, of writing clean code is, of course, to find a way to reduce the technical debt. We're probably all familiar with the paper that's of probably 8 years ago, the high credit risk interest technical, which of course is still relevant today. And I'd love to know, in your opinion, what are the forms of those technical debts that data scientists should be aware of today? And why in general do ML products incur such technical debt?
Yeah, it's a very good question. When I was at PyData, I created an entire section of my presentation on that, because what is the definition of technical debt? So it's a lack of agility. Agility means that you can change fast, right? And usually data science teams can end up in a situation when they are very slow because the problem is complicated, so the solution will be complicated. But if they don't take care of the structure of this complicated solution, then they are going to be hard to keep it in their head to maintain it in a consistent state. So they start breaking down and they start making bugs, and then they hunt bugs and then they slow down. This is usually not thought of as technical debt. This is usually thought of as technical mess. It means that you didn't care about your work. Now it's broken. That's not really technical debt. Technical debt is when you say, okay, I'm going to make this call that we are moving this direction because we don't have time to write around the structure, and then we don't have enough resources to commit to this solution. All right. So it means that we will going to try out, and if it doesn't work, we can back out. But you need to know how to back out. Now, if you have a messy structure, you can't make these calls because any kind of change will going to possibly ruin your project, and then it's very hard to get back to the state where you were originally. And this is what's the distinction between technical debt and technical mess. And machine learning, just to get back to why machine learning is very prone to collect technical debt or technical mess, is because it's very hard to specify it. So it means that no matter how careful you are going to end up missing some details, and then you need to figure it out how to incorporate those details once you already shipped or once you already committed to the project. So you did something else. And this is the essence of agility, right? I do something without knowing where I am going, preparing for that I'm going to figure it out later, right? So you need to design your structure, your projects like this.
Yeah, that's quite an interesting observation. Thanks, Laszlo, for sharing that. So once again, if you're in the audience, you can leave your questions in the chats. Also, if you're LinkedIn, you can also leave your questions in the comments. We'll definitely find a way to get to them. So we'll jump right into some of the community questions that were submitted before now. And this person asked in the community, what process would you recommend for transforming code from experimentation notebooks to production scripts?
Good question. I highly recommend to read my Refactoring the Titanic example, which comes with its own GitHub repo that takes you through step by step. It's kind of like the same list of to-dos, what you can see in the hierarchy, code quality hierarchy of needs, but that's a concrete example. I would not go through this. I highly recommend to read the article. The community is discussing this as we speak, how to make it even more approachable. I do think that anyone with any kind of background in data science should be able to follow this and practice and then get used to how to think about and managing your code.
Yeah, and I think refractoring is one of the questions that, okay, this person asks that, could you share case studies and examples where code refactoring and other like technical debt mitigation techniques helped a team optimize their ML products? Are there case studies you have?
Yeah, it's hugely. So essentially, how did this come about? So my previous company, I was head of data science, where I built a team around this, worked in industrial scale natural language processing for investment banks. Our question was, how does a 3-4 people team creates machine learning products that are bought by some of the most demanding companies in the world? And then we were really, really struggling. Like, we have no idea how to solve this. Like, NLP was like pre-LLM based, so transformers were just very new. And then we were looking for ideas how to make us better. But I was thinking, like, the software engineers doesn't seem to have these problems what we have. Like, what do they do? And then how can we take some of their ideas and see if it applies to machine learning, deep learning particularly, and in just general managing our code? And it turns out that a lot of them were very helpful, and we sold a lot of licenses to a lot of companies and had a workflow that otherwise with, let's say, a custom, like a standard MLOps stack, you are unable to manage, because it was like a complicated human in the loop model where you need to continuously update based on distance supervision, which is like a synthetic data generation technique. These are all very involved process questions, and process questions needs to be implemented in code to take effect, but you do need to able to write good code, and you can't just like manage this in data frames, right?
Yeah, quite interesting. Thanks. And another question from the community. So if we have ML and DevOps engineers on our team, is it necessary to help our data scientists undergo coding practice training? That would seem to us like an additional burden, but I want your opinion.
Yes, I definitely think that code quality, how a typical workflow happens, right? So it means that the data scientists are working with stakeholders and non-technical people or business units to solve some kind of problems. And then they hand over, let's say not hand over, but collaborate with deeper tech teams like software engineers, DevOps, MLOps engineers. So essentially, the idea is of clean code is that you maintain close relationship with the business while maintaining a higher quality code than you would otherwise do. It means that it's easier to collaborate with software engineers and MLOps on the other side. So it means that you are essentially respecting their time better, because it means you're not saying that I don't care about where my code goes. I am going to collaborate with you to raise my standard so you are easier to work together. I do think that very strong community or team spirit building thing, because machine learning is so collaborative and so like cross-functional. You do need to have these kind of organizational principles that people are willing to work with each other, because you can also hear a lot of these negative feedbacks. It's like, oh, you guys are chucking over the models, and the software engineer saying it's like data scientists are noobs and they don't know what they're doing. These are like bad vibes in a team when you are supposed to work together. And then if you both raise your standards, then you can progress forward.
Awesome, thanks. So we have a question in chats by Ganesh, and Ganesh asked how to safely remove or mute unused features while in production. Is it relevant?
Okay, that's interesting. It's usually you would have some kind of like, first there is this concept of complex behavior is constructed, not written, right? So essentially you have some kind of declarative place where you are defining these models, right? You can't just remove a feature from the code if it's written in it, right? So you need to have a pull request or something like that. And I do think that obviously you need to test it offline, and then you need to have like a deployment scheme to pass through to safely remove something, because otherwise your modeling assumption, modeling hypothesis might not be valid anymore, right? So, and then you need to have this kind of cascade of steps, how a model is deployed and how these are compared to each other and validated. This is how I would do.
All right. So I hope that's Swetra and Ganesh. Another question from the community. What is the best way you have seen code reviews work for ML projects?
Oh, yeah, this is very hard. Yeah, because I think this is what we usually emphasize, that what is exactly you are looking for in a code review, right? So we had this client on the West Coast. They had some kind of tech debt issues, and they said, okay, we are going to do mandatory code reviews. And the data scientist was asking, well, what are exactly we are looking for? That's when we turned up and then trained them to what actually looking for. Because often people say it's like, all right, you worry about naming conventions, or you are worried about bugs, right? Code review is not going to find you bugs. The tests are going to find you bugs, right? And naming convention is a convention. When you are submitting a pull request, you are supposed to obey that convention. It's not like I'm going to use single letter variables because I can get away with it. Maybe you are going to miss it in the pull request. How does it work as a communication? So the important part in code reviews is you are asking the other person, like, do you get what I wrote, right? That should be the level of abstraction, all right? Like, this is how I solved it. Do you get it? It's a relatively high level conversation. And then the other person says that, I think I don't understand this. I would think it would be better in a different way, right? So this is like a collaborative exercise where you are sharing the idea. And then obviously this is a primary way to telegraph your code, to distribute your code. People will going to know how you solve the problem, and they will going to know it now as well. So this is, you turn it from a chore into a collaborative exercise. And I do think that's an important part of code reviewing.
Right. Awesome. So we have some questions and chats by Mihao, and he's asking, how do you deal with features which changes as processing library change?
In Python, everyone worries about import statements, package. Is it about packages, package versions?
I think it's the library that you use to build those features and deploy as well.
You should think about package versions as part of your code. That's the best way. You build a workflow that creates, let's say, tickets for the next sprint of moving from one version to another. I sit through this with several TensorFlow versions, especially from the ones to the twos, and these are very big deals. And these are well invested time. It's not a afterthought of moving from one scikit-learn to the next, NumPy to the next. It needs to be deliberate, and you need to think it through. And the team should organize a workflow that, let's say, how do we check that every single model what we have is not going to fail because there is a different singular value decomposition algorithm in NumPy? This is an important question, and you need to. But if you maintain your code quality, then this is going to have a place where you deal with. And this is what, when I was speaking about layers of abstraction, we're going to get a ticket for a week to think about this and then figure out how to do that and then do it. But at the same time, they don't need to worry about that. Oh, actually, this KPI needs to be higher 10% this week, which is a very high level problem, right? So this is what layers of abstraction in practice means, okay?
Yeah, and he has a follow-up question, and I think this is really all about managing those dependencies in production when you, of course, deploy the systems. And he's asking if a new model needs like records from like both the old version of the library that was used for the feature processing as well as the new version, and do you backfill the features with the new version somehow?
Yeah, an issue depends. In a situation like this, first of all, you need data lineage. So essentially, you would think about every record you ever make is having hash commit next to it, or the commits hash of your repository when it was at the time. So you can go back and check that this record was created by this version of the package, and this new record was created by this one. So this is one thing what I would definitely do. And this is like a standard MLOps practice. The second thing I would look at, when the person moves from one package to another, don't forget, so there was a person whose job was to move your team, or at least one part of the team, or experimentally to one package to another. That person's job, part of their job, was to evaluate whether this is an important issue, right? Because you don't know. Maybe we're going to have a bug that we're going to take down your entire model. Maybe it is nothing. Like this was a situation with TensorFlow 2. We waited maybe about 3 months after we started experimenting with it to move into it, because there were like bugs in it which took down our production pipeline. And this should be part of the conversation when you are issuing a ticket to move from one version to another. Or like, is this a problem? Because if it's not a problem, they don't worry about that. They just move on and use the new data and don't worry backfilling the data. Okay?
Yeah, right. And speaking of dependencies, we have a question from the community on how do you manage dependencies for your ML project?
Okay, it depends on what dependencies. I usually recommend to have a system-wide or a team-wide golden path of workflow. It means that how do we create new virtual environment? What kind of packages we are using across the team? And then you can share this across quite a lot of people and then say, it's like, okay, there's a new NumPy version. I'm going to figure out whether it's actually good for us or not, right? And then we bump version, and then everyone can bump their own versions as well. That's one thing. The second one is using custom code, like import statements, export. How do you structure your project? And this is an important issue when you kind of build a workflow once. And this is not really added value or a distinguishing factor. So it's like, fix it one way, distribute it to every people, and then say it's like, use this, and then you get these values, right? You don't need to worry about it ever again. You know how to import statements and so on and so on. And it's like simplify where you can, because then you open mind space, and then you can think about like actually value-added problems, all right?
Yeah, that works. So we have another question in the chats, this time from Ayu, and he's asking, how do you release new, better models in production environments without much downtime? Quite a lot of production-related questions today.
Yeah. It's usually, I spoke about this. So essentially, you have a predefined cascade of tests that you are going through. I usually speak about like starting at refactoring, because don't forget that there is this concept of exploratory operational symmetry. Google saying is like, okay, we are running the same code between production and experimentation, all right? So it's the same code running everywhere. And I think this clean architecture and all of these concepts are saying that you only have one version, because if you have only one version, there is no friction. I change something on my machine, and there is a cascade of how does it turns out that I'm not going to lose 10% on an important KPI. All right. So it starts with refactoring, edge cases, unit testing, then like a cascading of larger and larger sets like 10%, 50%, 100% tests, testing in live, testing in canary, A/B testing, and then you are deploying, right? But you are using the same code throughout these pipes, and then you're looking, is there some reason I should not move forward, all right? And what can be that reason? Because often machine learning bugs or problems appear as like statistical problems. So these are very involved to figure out. It's not just like, all right, I'm getting back a null, I'm not checking that. So it's like niche questions.
Yeah, thanks for the question, Ayub. Thanks for your response, Laszlo. Speaking of EOS, you spoke briefly about EOS, and this particular person asked in the community, if we want to start thinking about EOS and refactoring for an existing project, where should we start from, or what should we start with?
Yeah, if you maintain a certain standard of quality over a period, because don't forget, a lot of project doesn't have a production. It means that you're not making EOS because there is no E, isn't it? So that's a problem. So usually what we recommend is like maintain clean architecture. It means that you can deploy the same code in different contexts. And once you are in a state where you can think about production context, then you are going to be well placed that you can refactor your code as it is to maintain EOS, all right? And this is exactly what the benefit of refactoring and clean code and clean architecture is, that you don't worry about this. We will going to solve it. We know how we are going to solve it when we are get there, all right? Because we know how to edit our code and not going to stuck in some state where it's very hard to move to the next stage, all right?
Yeah, awesome. That works. Okay, so we'll jump right into the next question. And this person asks, what do requirements understanding and development contribute to clean code practices? That's from the onset, thinking about the requirements for the product. How much do they contribute to clean code practices? Yeah,
it's relatively less. Obviously, like again, this is like a layers of abstractions question, because you can think of as requirement or business requirement. These are not questions about how do you manage your code or what repositories, dictionaries you have in your repositories. These are high level questions. And clean code enables you to worry about those, all right? And then you have like a path, how do you going to turn it into code and how do you ship it? So that's one thing. The second one is like all kind of DevOps related problems, which enables you, because you are defining your solutions as like clean code. So that's your solution. It's not an abstract model that your solution is, which has like certain features and performance characteristics. No, the code is your output, right? And because this is in a maintainable state, it means that software engineers are more keen to deal with it. It means that you have a better relationship with software engineers, and they will, if they are facing some kind of SLA problem, which is usually what you have, they are going to be more keen to collaborate with you to resolve these problems, right? Sometimes something needs to be rewritten. No one knows that Python will not going to perform at this level. If you hand over clean code to the software engineers that to rewrite, let's say, a Python code into Go, they would be much more happier and work with you and help you along the road, right?
Yeah, awesome. Thanks. So another question from Ayub in the chat, TensorFlow 7 or some other deployment tool, which one would you recommend?
Oh, I probably not going to make it.
So impressive. Yeah, I get it. Yeah, it's fine. It's fine. It's all good. So Ayub, you can follow Laszlo online. Probably you might see something. Who knows?
I usually consider clean code and clean architecture, and our consulting practices are relatively high level. Mm-hmm. So we usually deal with business problems and team problems and organization training. And you can see that clean code is usually rarely goes into MLOps because these are like abstraction levels. And I kind of think that we publicly focusing on the top layers, because that would be a more beneficial way to move towards the bottom, which is software engineering is a relatively strict business where there are more best practices. That's why I usually not committing myself on technical issues in that level.
And speaking of tooling, I think there's always this sort of argument or statement that you should choose tools that really force you to follow best design, like best coding practices or design patterns. The argument of course, Kubeflow, for example, that helps in some way, forces you to use some form of design pattern in to sort of develop your system. How would you sort of think about this? Is this a problem that data scientists should think about, or?
Yeah. It's usually, I don't think that data scientists are particularly invested in MLOps. I don't think some of these issues are too low level for them. This is an intuitive way. Obviously, if you work for a startup, then again, you need to do both. Just try to bound this or time box this so you're not dealing with everything at the same time. But from a data science perspective, these should be decoupled through clean architecture. It means that you are not going to see these as tensor serve. You're not going to know how your model is going to be served. You're just going to see APIs. Even if you need to call one, you're going to wrap it with a abstract Python object, and you can forget about how is it going to do it. Because this allows someone, and this is the core concept in clean architecture, is you are allowed to suspend decisions until the very latest moment, right? This is the point of clean architecture, is like, I don't know which way the TensorServe or NVIDIA's latest work is the best way to deploy a model, but there is a way to figure it out. And I would like to be in a position to make this call when we are there. But until then, I don't want to think about this, all right? Because I don't know now. So
awesome. Thanks for the response, Laszlo. And we have a question from Matthew, and he's asking, or he asked, do you have a specific workflow for tracking model experiments that don't apply on third-party libraries? We are trying to move away from the tooling. Listen, but I think maybe workflow is probably a...
I don't want to mention names, so I would...
Yeah, I get it. That's totally understandable.
But just recently, we were working with a client, and we need to make architectural choices. And one of the biggest problems was lock-in. It means that they didn't want to use a product where they think that they are limiting their choices. The second is who's going to use it, all right? So data scientists, like, that's great, you picked one product, but how are we going to find data scientists who can do that? And this is where clear architecture came in as an escape tool, because we said that, okay, we are going to express our system in clean architecture, which means the data scientist doesn't need to know how they work, right? It means that they are not going to produce code that is locked into this architecture, and therefore you are going to have the choice of decision later, all right? It means that the decision now is much lighter because you know that you're not committing to this platform for the next 5 years, all right? And this was an important realization just recently, that we can sell clean architecture with this idea.
Yeah, quite interesting. Thanks for sharing that. Another question, and this time from a data scientist in our Discord community. What's your opinion on glue code? Should it be avoided entirely, or should data scientists still use it in situations where they can?
Yeah, it's interesting because I usually think about when people say glue code as a red flag, is you are still not thinking that your code is a first-class citizen. Your output is code. You can't just say glue code, because you would think it's like, hold on a second, you think this is not important? And it's interesting, you mentioned the hidden technical of that article, and Google speaks about code as glue code as well, despite being Google. I was surprised that they have this concept as well. Like, it's just code. You're just connecting systems to each other. Usually, you need to have some kind of structure and some kind of interface and some kind of coherence about how do you express your system and why do you need to deal with these low-level details. That's a sign that your system is incorrectly defining the interfaces and responsibilities or concerns what some code writer needs to worry about. You ask a data scientist to write continuously Docker containers and Helm charts, that's not going to happen. That's a problem. You need to have a better workflow for them and figure out this abstraction. And this is exactly layers of abstractions. You want everyone to operate mostly in the same abstraction, not too much context switching, and especially no context switching between various layers at the same time.
Yeah. Thanks for sharing that, Laszlo. And another question again, what role have you seen ML testing play in reducing technical debt?
As I said, there is no technical debt removal without refactoring, and no refactoring without testing. So it means that, like, essentially, you need to have any kind of testing from day one. All right. So you need to figure that out. How do you know that I changed something and it didn't break my system? All right. That's essentially what testing is. It doesn't need to be unit testing. That's a very important thing. So should not be burdensome. And Kent Beck has a very good video on that called 3x Explore, Expand, Extract, which describes his experience at Facebook. Facebook at the time didn't write tests. Ken Beck was like the original TDD guy, like test-driven development guy, and he had this kind of existential crisis of like, how is it possible I spend my entire life on this, and then these guys are just like super successful without my message? And then he figured out of why this is happening and moved into a higher abstraction level, because I figured out that Facebook is so large. If you make a mistake, you will going to see it. Your servers start falling down, and then you know that you need to start undoing it and then going back. So it means that it's not really test is that important. It's the fact that you know that your system haven't changed, right? And in terms of testable code, the reason why testing is so important, because you can write testable code. If you can test your code, then your code is well structured for all other problems as well. And this is why testing is so important.
Right. Interesting. Thanks for sharing that, Laszlo. So once again, if you have any question, maybe you want to ask anonymously, you can send that to me directly, or you ask in the chats wherever you're streaming this particular episode from. So Laszlo, how do you develop a testable architecture for your ML project? And you've talked about how necessary it is, of course.
Usually we are starting with some kind of experiment. This is relatively short term. We usually separate analysis from actual code. There is code which we think of as shipping. This is going to be our system. And then there is things like, okay, I don't have a database, I don't have a visualization or observability. I'm going to do that in pandas. And then I'm just getting the data from this kind of proto system and then start reading and then looking at whether it works, right? And then think about the data flow as it goes through the system. It has some kind of source, and then at the end have some kind of sink, and then start working through this and then implement what we think as like a big picture idea, like a pipeline. Right? And then think about the code quality issues of like, are we maintaining this? Are we going into a direction that we can't back out? How is it going to look at the system? And as we progress, it's going to start looking better. And at the same time, when we are in a state that we say, this is right, you make a checkpoint, you save how it looks at the moment. And then next time you run your code, you would like to see the same results. All right. And then if you change something, you would say, I want my test fail in this way, because was the only thing what I changed. Like a very simple idea is to remove a column from a data frame. You run the test and 2 columns are missing. There is something wrong. And so you need to go back and then recheck, why did you drop 2 instead of 1? And these are like the logical loop of how do you think about progressing with the system. And obviously, when you have an end-to-end system, then you say, it's like, okay, I think this is a POC, all right? And then you would say, it's like, okay, what did we miss? How do we want to move forward? What kind of other options there are? How clean architecture is? What kind of experiment we would like to do? Which means that usually experimentation appears as using the strategy pattern, and you need to break these strategies out of your existing system, because maybe at the point where you would think you haven't thought about that, you need to extract that and then plug in a different part. And then you start to have this kind of flywheel of experimentation.
Right, Professor. Thank you for sharing that. What are your best resources for data scientists to learn how to write clean code?
There are like the classic books. One of the important concepts when you're reading clean code books that are written for software engineers, that not everything applies to machine learning. These are really different paradigms, and you can easily end up in cargo culting, for example, and then you're doing things because the software engineer is doing it, but they are solving different problems. This might not apply to your state. So this is just a caveat, but when you can capture the essence of these books, then you understand that it's like, okay, how do I apply it to my problem? Do I have the same situation as in the software? Does it apply to my situation? And then the progress forward. So I used to read a lot of YouTube videos, watch YouTube videos. You can read my blog as well. So this is like a collection I try to write about when I find something, a blog post, and then assess what parts are relevant for data scientists.
Yes, and Laszlo also started a community recently. So I think that's a valuable resource as well that people can definitely check out. We'll link to the community in the chat and show notes of this particular episode as well. Also, I think we're delving right into towards the end of this particular episode. But I'm curious, what do you think are the most useful and essential skills in code quality that you teach every data scientist? Of course, you've mentioned quite a number of them, but in summary, maybe this.
Yeah. If you need to have one thing you need to learn, but that's the problem, is that that's relatively high level. Dependency inversion is the most important concept, I think. I think that's relatively low around the decoupling on the here or need, because obviously you need to enable yourself to get to that. But if you reach that and you start thinking, if you can capture how do you break problems up into smaller components? How do you not get committed to certain pieces of your code? How do you write code without fear of changing it? These are all coming down into this part. I wrote about that. You pretty much only need 3 design patterns to get started, which is adapter, factory, and strategy. And these are all aspects of dependency inversion. So it's a key concept of in this whole.
Yeah, and could you spend a bit more time talking about those sort of useful design patterns that you've found that have encouraged coding practices for you?
Yeah. So essentially, these are all treating some kind of feature of your code base, feature in the sense of like something that it does, not in the modeling feature, like a part of the code as an external resource, right? If you can treat it as an external resource, you can swap it to something else, right? And then you don't need to worry about what's behind this. And this is decoupling. And this is part of that layers of abstraction, problem decomposition, bounded context thinking that I am going to organize my work in a way that at the same time, I am only worrying about one part of the system, right? Because everything else is external resource to me. I'm connecting to them through APIs. And this is the same as strategy, which is treating algorithm as external resource, adapters, which is treating external resources as external services as external resources, and factories, which are treating data sources as external resources. So your code doesn't worry whether you get data from a file or a database or something else. You don't need to worry about that because you are just to get data in an abstract form, and that enables you to forget about that, all right? You just need to know what you are getting, not how you are getting, right?
And when you talked about the interaction between like these different services, and correct me if I'm wrong, the mind automatically goes to maybe microservices architecture, for example. And how relevant do you think it is for maybe like an ML engineer to learn about these things, like how to build all this?
That's an interesting question because usually I consider microservices as a very low-level issue. You are reaching that point where you have a very deep understanding of your system. You know that you don't really know where bottlenecks were going to form in your system. But if you think in a different way about this, you can say, what's the abstract equivalent of a microservice, all right? What's a microservice? It's an instance somewhere which has a Docker component. On top of that, there is some kind of API. And on top of that, there is some kind of object, a class, all right? And that's exactly my thinking is that if you start breaking down your code, clean code architecture into classes, then when you are shipping this code, the software engineers are going to understand the structure and they can say, it's like, okay, this is a service, all right? I'm going to wrap it with a service, and then your flow into production is more smooth, right? And I think this is an important concept is like of clean architecture again, is that I don't know which one are the services, but I am writing it in a way, if it turns out to be a service, then the person who has come after me to fix this, we're going to be in a much better position. And I'm trying to express myself in a way that is natural to them, all right?
Yeah, and this next question is a bit of a controversial question, but anyways, I'll throw it out there. And can good coding practices happen within Jupyter Notebooks?
I know you're going to say this. Okay, yeah. So you are not unlocking the benefits of like modern IDEs if you are writing code in notebooks, right? In some sense, it's the same. You're typing Python code into text boxes or windows. But I do think that mixing these two is very inconvenient. And we usually use our notebooks as an analytical tool and sometimes as a CLI, all right? So essentially, you're building a context and you run it as it is. But these are integrated things. You're not making categorical decisions. We use both, not a big deal.
Right, yeah. We have a question in the chat by Christian, and he's asking, what are your recommendations on data drift monitoring and drift monitoring by feature for production environments? Are there practices you recommend there?
Yeah. So obviously, apart from not naming names, but model drift, like the most important concept in MLOps is lineage. All right. So it means that when you are recording the information, you are aware of the context that information was created in. That includes knowing what kind of models were using, what kind of data those models were created on. And you have a lineage. And this is exactly why you need to have a very strict version controlling, because that version control is that lineage for your code. Right. And once you have that, then you can do experiments and you can test whether or the assumptions what we had in tests or evaluation or training are still valid in production. Why? Because you know that these data and the statistical parameters in a data lineage way, right? So it means that when you have a statistical parameter, it just doesn't say your correlation is X. It says correlation is X at this time, at this calculated, this was a data preprocessing pipeline, this was how it was changed, and you became more conscious if you record more, right?
Very interesting. Thank you for sharing that, Laszlo. And as we come to, of course, the resolution of this, what are some other software engineering ideas you think data scientists can learn to write clean production level ML code?
More. I usually try to express myself as few components as possible. I do think that clean architecture, bounded context, and this kind of high-level organizational principle is one of the most important things what you need to do. And at lower level, to deal with the hierarchy of needs. Having a good workflow, that's the first thing, because it means that once you have it, you don't need to worry about. Like I use a environment making script for 5 years now, 10 lines. I don't need to worry about how do I create virtual environments because I have the same code pasted into every project I do. Once you've done that, practice is very important. It means that you need to get used to changing your code, pull requests, someone look at this, I don't think this is good, or this is a great idea, I'm going to take it and I use it on my project, and just keep practicing, right? This is a craft, and craft is not something you learn in theory, something is what you do and you get better while you're doing it.
Awesome, perfect. As we, of course, reach the resolution, how do you structure ML projects to reduce technical debts? Where do you start thinking about the problem? Something you can summarize for us?
This is an important team organizational principle, because it's very hard if half of the team wants to organize something and the other team is not just doing their own business, you can end up maintaining their code base. And this is important to train everyone to be in the same mind space, all right? So it means that new members are trained by senior members, the junior members are allowed to contribute very early on so they can progress as well. That's the first step. So this is like an organizational or a people part of this question. The second part is process. As I said, machine learning projects are very prone to unspecifiable issues. It means that even if you are very careful, you're going to end up in missing important parts. So you need to have good time box steps on each of them, and then have a way of getting out of this. And this structure, like a generic structure, is defined by the team for every project they do early on. So this is just how you make projects, right? You don't need to justify that I'm going to use clean architecture, and someone would say that doesn't add business value. If you have this kind of conversation, you are going to have a problem, because it's always very hard to say something makes money early on, all right? But if you say it's like team accepts that based on our experience, using clean architecture is beneficial in general for the project, then we don't need to, this is the golden path. From day one, we are going to do that.
Yeah, thanks. And of course, to wrap everything up, summary, high level, how do you fix an existing ML project with bad code quality?
Yeah, I'm going to point you to the refactoring the Titanic example,
absolutely.
which is only 20 lines, but there is 24 steps of detailed explanation of how to do that. And of course, join our community and be part of the conversation about how to solve these problems. But it does take time, and it is much harder to do it after it was created than at the very beginning.
Yeah, absolutely. So I'm going to be leaving all these will be in the show notes, the link to the community, as well as that particular article will be the show notes, as well as the Zoom chat here. So thank you so much, Laszlo. We don't see any other question coming in. So it's been a great episode with you. So where can people learn more about your work? Of course, you've talked about your blog. Is there any other place you're active a lot more?
Yes, please feel free to reach out to me on LinkedIn. And I'm sharing my content there usually, and subscribe to my blog. I think that's the two best places.
All right, perfect. Awesome. So we've come to the end of this particular episode. Of course, hope you enjoyed it. If you have any more question, or you want to, again, connect with Laszlo, you can do that, check LinkedIn, or also join the MLOps community. Then, of course, say hi to Laszlo and then interact as well there. So we'll be back 2 weeks' time with another episode. And this time we're going to be talking about intersecting DevOps with ML lifecycle with Shisha Ray, who is the Director of Engineering at Thomas Reuters as well. She's going to be talking to us about how they apply DevOps principles in their machine learning lifecycle. So don't miss that episode. And otherwise, see you next time. Bye.
Bye. Thank you very much for hosting me, Stephen.
Yeah. Bye.
Bye.
MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. And you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.